Let us start our discussion with stack. Stack is a linear data structure in which insertion and deletion of elements are performed only at one end, called the top end. The stack follows the principle last in first out. It means that the last element inserted is the first element to be removed. And the very first element which is inserted, it will be the last element to be removed. Look at this diagram. Here, this is the top element which is present on the stack, and it is the first element to be removed. The very first element inserted is this element. This is the last element to be removed. After removing all these, this is the last element to be removed. This is how to understand last in first out. We always remove the object from the top only. This is because in a large pile, it is inconvenient to add or remove an object from in between or bottom. Such an arrangement of elements in a linear order is called a stack. Coming to the application of stack. Some of the applications of stack in real life are a pile of clothes in almirah, multiple chairs in a vertical pile, bangles worn on wrist. Coming to some of the examples of stack application in programming language. Number one, when we need to reverse a string using any programming language, we can go for stack. When we use text or image editor, we have the options like redo and undo. These two options requires stack. While browsing the web, we move from one web page to the another web page by using the links between them. In order to go back to the last visited web page, we may use the back button on the web browser. There we need the application of stack. While writing any arithmetic expression in a program, we may use parentheses to order the evaluation of operators. There also we need the application of stack. Coming to the operations, basic operations performed on stack. We have two operations, push operation and pop operation. Push adds a new element at the top of the stack. It is an insertion operation. Pop operation, it is used to remove the topmost element of the stack. That is, the element at the top of the stack. It is a delete operation. Let us write a simple program to create a stack using Python. The first step, we have to create an empty stack. In this example, the name of the stack is given as glass stack. Now an empty list is created and that will be assigned to a stack. The second function, we have to check whether the stack is empty or not. For that we can use isEmpty function. This is a user defined function. Here there is one parameter called glass stack. If the length of the glass stack means stack, this is the name given for stack in this program. When the length of the stack we will get 0, then I can say that the stack is empty. Suppose if the stack is not empty, this function will return false. Coming to the another function named op push, it is a user defined function. It is used for inserting a new element into the stack. This function has two parameters. Look at this. Number one, the name of the stack. Number two, the element to be inserted. Now we use a built-in function called append to insert the element into the stack. As you know, there is no limit on size of list in Python. We will never face the condition like overflow in case of Python when we use stack. A function named size to read the number of elements in a glass stack. We will use the length function of the list in Python to find the number of elements in the glass stack. Now we'll go for this function named size. Using the length function, we are finding the length of the stack. To read the topmost element in the stack, we can go for a function named top, where we have one parameter, that is the name of the stack. And there is one function isEmpty. When this function is used, we are finding whether the stack is empty or not. If it is empty, we will print the message stack is empty. Suppose if it is not empty, then we will find the length of the stack and that will be assigned to the x. Now this statement assigns the topmost element into the variable element. Now that element will be returned. A function named OP_pop to delete the topmost element from the stack is used in this program. It takes one parameter, that is the name of the stack, from which the element to be deleted, and returns the value of the deleted element. Before performing delete operation, the function first checks whether the stack is empty or not. If it is not empty, then it removes the topmost element. If there are no element present in the stack, it cannot remove an element. Then there will be a condition that will be arised in such a situation, that is called as underflow. Look at this function. This is the name of the stack. Using this if condition, you are finding whether this stack is empty or not. If it is empty, you cannot perform insert or what you call delete operation. You cannot perform delete operation. If it is empty, if you try to delete an element which is not present in the stack, it creates a situation called underflow. If it is not empty, this function, a built-in function called pop, will delete the element from the stack. Another function named display is used to display all the elements present in the stack. Using this function len, you are finding the length of the stack and it will be assigned to the variable x. Then you are writing a for loop. As you know the length of the stack, you can write a for loop. After writing the for loop, this print statement will be repeated based on the number of elements present in the stack. This print statement prints all the elements in the stack. Then let us discuss about notations for arithmetic expressions. Look at this: x plus y, 2 minus 3 star y, etc. Or this equation may be written within parentheses. These are all called as infix representations because the operator is in between the operands. X is an operand, plus is an operator, and y is an operand. Now the operator is in between these two operands. Now we can call it as infix. A Polish mathematician in 1920 introduced a different way of representing arithmetic expression called Polish notation. What is that? Look at this. This is an infix expression, x plus y. Now we can write the operator before the operands plus xy. This is prefix notation. And also, if you write xy plus, it is called as postfix notation. Look at this. If you write xy plus and the operator will be written after the operand, this is called as postfix notation. Look at these examples. Infix, x star y plus z. Prefix, plus z star xy. Postfix, xy star z plus. Look at this. The operator is written after the operand. Here the operator is written before the operand. Now here the operators are in between the operands. So this is infix notation, this is prefix notation, and this is postfix notation. Let us discuss about an expression which is converted from infix to the postfix notation. We have an expression within a bracket x plus y and a slash within a bracket z star 8, which is to be converted to a postfix expression. Now look at this, we have a left parenthesis that will be pushed into the stack. Then we have an operand that will be added to the postfix expression, means it will be appended to the postfix expression. Now we have plus that will be pushed into the stack. We have an operand, that operand will be added to the postfix expression. Then we have a right parenthesis. When right parenthesis is encountered, we have to pop up all the elements until you will see the left parenthesis. Now we have a plus here that will be popped up from the stack and it will be added to the postfix expression. You have a slash here that will be pushed to the stack. Then we have a left parenthesis that is also pushed into the stack. Now we have z, which is an operand that will be added to the postfix expression. We have an operand star that will be pushed into the stack. Then you have an operand 8 that will be added to the postfix expression. Now you have a right parenthesis, then you have to pop up until you will see the left parenthesis. Now we have a slash that will be also appended to the postfix expression. So now this is the final postfix notation expression obtained. Look at this diagram based on the same example. Now you are pushing left parenthesis into the stack. Then you are adding x to the postfix expression. Then you are pushing this operator into the stack. Then you are adding operand y to the postfix expression. After that you will see the right parenthesis. You will pop up everything. Then you will put slash into the slash into the stack. Then an open parenthesis, left parenthesis. Then operand z that will be added to the postfix expression. Then an operand star that is also inserted into the stack. Then you have 8, which is an operand that will be added to the postfix expression. You will see the right parenthesis. When you see the right parenthesis, you have to pop up all until you will see the left parenthesis. Now everything is pop up. So this star will be popped up and it will be added to the postfix expression. Then you will see the slash that is also popped up and it will be added to the postfix expression. So this is the final answer when we convert this infix expression, infix notation expression into the postfix notation. My dear friends, if you feel that our videos are informative, please subscribe, give like and comment and share our videos. Thank you.